We will see general system of optical communication in this video. So in this video, you're going to study how the optical communication is working. So basically in the communication system, what what are the main components which you can notice? There is a transmitter here. Okay, so there is a transmitter here. So this is a transmitter. Then there should be a receiver, and in between there should be a components which is responsible for carrying a signal from transmitter to receiver. So those components can be a waveguide. Okay, those components can be a fiber. Okay, or any other media through which the signal propagates. So in this we are going to study optical communication system. So here we are going to use optical fiber as a guiding waveguide. Okay, for a wave to propagate, we are going to use optical fiber for carrying the light from transmitter to the receiver. So let us see first what is the input to the system. So here the bold line indicates that it is an electrical signal, and this it indicates an optical signal. The electrical signal which is input here is given to a transmitter. So we know, we have studied in the previous lower semesters that a transmitter is having or input signal, and that input signal is what it is encoded or modulated and amplified, and then it is transmitted. So in the same way, transmitter also does all these functions. Okay, modulation is happening, encoding is happening, amplifier is happening. There is a sequence that a signal which you feed to the for a signal which you feed in order to send to the other end should be first encoded, then it should be modulated, amplified, and it is sent over a channel. So in our case, what is happening? So this transmitter, it is including all those things. Yeah. Along with that, there is one extra thing which is happening here, which is electrical signal is getting converted to light signal. And this electrical signal is this drive circuit, it is converted to a light signal. Okay, so this is happening through intensity modulation. By varying the bias current, you are going to vary the intensity, and by intensity modulation, this electrical signal is converted to light signal. So this light signal is coming out of this light source. The light source can be a LED or it can be a laser. Okay, so LEDs if you use, then it is a short distance communication it is used for, and if you use laser, it will be for long distance. So for long distance communication, laser is used because it is also having a high efficiency compared to LED, and it is also having a high directivity compared to LED. Okay, so this light which is coming out of the source is should be coupled to the fiber. For that, we are going to use a fiber violet. As you see here, if the light is getting out at this end, not all the light is getting into the fiber. So in order to launch the light into the fiber, a fiber violet is connected here, which connects the fiber to the source so that the maximum light is coupled into the fiber. Okay, and then you can see that this light is getting propagated through this fiber, and in between there is a connectors and there is our optical splice. So connectors is what it is used to join the two fibers together temporarily, and this optical splice is used to join the two fibers together permanently. Okay, so when you compare connector and splice, connector is a temporary joint and splice is a permanent joint. So since it is a temporary, you can remove it anytime. And when you connect it, there might be a small air gap due to which there is a loss in the signal. Okay, this is called as Fresnel reflection due to the variation in the, or there is a drastic change in the refractive index. So in the connector, there might be a chance that the signal can be lost due to the small air gap when you join the two fibers or when you connect the two fibers. Whereas in the optical splice, there is a minimum chance that there is an air gap because it's a permanent joint and a special equipment can be used in order to join the two fibers together permanently. So that is called as splicing. Okay, so this splicing is permanent joint, hence this is not having any air gap between the two fibers. So the loss due to this splice is going to be less. Okay, so let us proceed. So the signal is propagating over a long distance. Okay, in between, if you want to connect the signal or if you want to divide the signal between the two circuitry, there can be a splitter here. Or if you want to combine the signal from the other circuitry into the system, it can be a combiner here. So it can be optical coupler or optical splitter. So here it is mentioned. So as and when it is required, we can use a coupler or a splitter to the other circuit. So coming to the next here. So in between, since the signal is traveling over a very, very long distance, the signal may get degraded as it travels. So in between, you need to place a repeater. So repeater is basically a regenerating the entire signal. Okay, regenerating in the sense it is going to take the optical signal, it is going to convert that optical signal into the electrical signal, and then from electrical signal, it will remove the noise, it will amplify the original signal. Okay, so when it is receiving, it will decode and demodulate the electrical signal from here. Okay, then the noise is removed, error is removed, and then again it is encoded, modulated, and then converted to the optical, converted, encoded, modulated the electrical signal, and then it is converted from electrical to optical signal, and then finally it is again transmitted. So basically in the regenerator, the entire signal is getting regenerated in the sense any error if it is having or any noise it is having, everything is going to get removed and then original signal is recovered and from there it is again getting transmitted. So this is indicating an optical splice. Okay, again after that there is an amplifier here. So amplifier will amplify the signal along with the noise, whereas regenerator will remove the noise and amplify. Okay, and amplifier is optical amplifier is what it will amplify along with the noise. So there is a difference between the optical amplifier and the electrical amplifier. So optical amplifier is what it is directly amplifying the incoming light. Okay, it is not getting, it will not convert optical to electrical and then amplify. So whatever light signal it is getting here directly, it will amplify light. So this type of amplifiers are also named as inline amplifier. Okay, because the light which is coming inline, it is directly getting amplified. Whereas electrical amplifier, it is amplifying, electrical amplifier will convert, uh, it needs to, electrical amplifier input needs to be converted from optical to electrical and then we need to amplify and then again we need to convert it into optical and transmit. So that is going to be more complex because there should be a electrical to optical conversion taking place. So whereas optical amplifier don't need electrical to optical conversion, directly the light is getting amplified and then it is proceeding further towards the receiver. Okay, so in the receiver, again we need a fiber flylight in order to couple the light which is coming out of this fiber, okay, to the photodetector. Photodetector means it will detect the light. Okay, so that's why it is called as photodetector. There are two types. One is called as PIN diode and one is called as APT diode. PIN diode is used whenever less gain it is there. So it is used wherever the less gain is desired, whereas APD is a high gain photodetector. Okay, wherever it is sensitivity is going to be high in APD, sensitive detection will be there. So gain is going to be high. So for effective detection, there is a APD can be used. So the APD or photodetector, API and photodetector converts the optical signal to electrical signal. Then that electrical signal is getting amplified here, and then the final processing of decoding, demodulating, okay, and recovering the original information. Okay, all these things is happening here in, and then it is the message can be recovered. So this is the entire optical communication system. Okay, so usually this question is asked for 10 marks. So you need to remember, basically in communication system there is important components: transmitter, receiver. Okay, in between there are couplers, in between there are regenerators, in between there are optical amplifiers, in between there are optical splice. Okay, usually transmitter is what basically modulation happens here, and the receiver, this basically demodulation happens. Now one more thing, where exactly to place this regenerator? Okay, can the regenerator be placed at any point? No. Okay, so regenerator can be placed. So we know that there is we have learned in the our lower semester a definition for skin depth. So what it is giving you? It is giving you a graph of distance versus amplitude. So initially when the distance is 0, the amplitude is maximum. That is at this point. It is at the beginning of the transmission at the transmitter. Okay, so as the signal is propagating, what is happening? The signal is getting degraded. The signal is getting degraded. So when the signal gets degraded, so this is the maximum value of the signal at the beginning. So you are going to measure where exactly the signal is 1 by E times the maximum value. So this value will be around 37% of the maximum value. So where the signal gets degraded to the 37% of its maximum value, there exactly you are going to place the repeater. Okay, so at this point the signal should be getting regenerated in order to recover the original information at the receiver. Okay, if we don't place a repeater at this particular distance, we cannot recover the original information. Is that clear?